So hi, this is my video number 13. I'm going to talk on partial derivative. Okay. Now, the definition is, let's say a function f is given as f xy. Alright. Then, if you wanted to differentiate respect to x, del f del x, or we denote as f sub x. This is the limit h tend to 0 fx plus hy minus fxy over h. So if you look at this definition, differentiate respect to x means we fix y. And look at this definition, y doesn't move, doesn't change, and x is changed from x plus h to x. Okay, so similarly, for if we differentiate respect to y, del f del y or f sub y, we take a limit h tend to 0 f x plus y plus h minus fxy over h. Now in this case, x is fixed, y is moving from 1 plus h to y. So look at the definition. Let's say we were given a function that x cubed plus x squared plus y cubed minus 2y squared. So we want to find fx to 1 and fy to 1. So for fx, so we have 3x squared plus 2x y cubed, right? And then we evaluate at point 2, 1. So we have 2 squared minus 2, 1 cube. So you can solve this. This is what? 4, 12, 4, 16. Right? For fy, I think you can do this. I just leave that part to you. Okay, let's see. If you use the chain rule, we select function or given function that we cannot differentiate directly. So another example that, let's say we have fxy that sine x over 1 plus y. Okay. Find fx fy, and another one, let's say we have x cubed plus y cubed plus x cubed plus 6xyz equal to 1. Okay, find zx and zy. Okay, where z is a function of x, y. Okay, so solution for the first case, then we want to find fx, means we differentiate that respect to x. So fx is differentiate signs, we got cos x over 1 plus y, then delta x over 1 plus y. Okay. We use a chain rule here. In this case, we use chain rule. So what? Simplify that. You have cos x over 1 plus y. This one is 1 over 1 plus y. that we differentiate this. Okay, for fy, we have that the function we differentiate respect to y. So we differentiate sine, we got cos x 1 plus y. Then we differentiate respect to y, everything in the bracket, 1 plus y. Okay, so that give you, this is cos x 1 plus y. Differentiate that, we got negative, I put it there, then squared. So we have x over 1 plus y. This one squared. That's what we have. Okay. For the second example, we have here. So in this case, we need to differentiate this implicitly. Okay, we need to differentiate that implicitly. So given that equation B, we have x cubed plus y cubed plus x cubed plus, this shouldn't be x cubed. No, we don't have this one, I think. Just that. Plus 6xyz. This is equal to 1. Okay. Now we want to differentiate with respect to x. So here we have differentiate that. This is just variable. So 3x squared. That one give you 0. This is, no, sorry. This is z cube. Okay, z cube. So this one is 0. That one we have. We differentiate respect to x. So you have 3 z squared del z del x. Right? Here, use product rule. So we have 6yz. We differentiate with respect to x. Then we differentiate with respect to y. 6y. So we differentiate with respect to z. Del z del x. That equal to 0. Okay. X. You're missing x here. Okay, then from there you can just simplify this, put x together, z dash together. So we have 3z squared, that one plus 6xy del z del x. Bring the rest to the other side, minus 3x squared minus 6yz. So del z del x, you can factor out of course the negative 3, so that gives you x squared plus y 2y z. This one you can again factor out 3. What left is z squared plus 2xy. Cancel out those things, so we have, this is negative x squared plus 2yz over z squared over 2xy. So that's for zx. Okay. Then for zy, I think you can do this. For zy, I'll just leave this as an exercise to you. Do it yourself. Right, so it's not difficult. Easy. Thank you.